actually see the amount of ink that's in these. The biggest issue though is that the issue is not with the ink, it's actually with the tip. So even though it can theoretically last 10, 20, 30 refills, the tip starts making mistakes or getting degraded right around 4. So it kind of defeats the whole purpose. And then here are the Osprey markers. So these ones are actually made just to be environmental. So that's their whole selling point. The marker and the tip core are actually completely replaceable. So you can actually take apart the entire marker. The biggest issue is that where they all refillable, they take 1, 2, 3, maybe 3 minutes just to do one, because you actually have to take apart the entire marker and use a dropper to actually drop ink onto it, which takes a long time. And you can imagine, if you're the whole classroom, you're thinking about 2 hours just to refill a marker. And to add insult to injury, a lot of people actually complain that they need to refill it a lot more than they thought they would.
Next, we're going to talk about how we went about figuring out what we needed to do in order to solve this problem. So first, we talked to a variety of stakeholders, all teachers, because teachers use whiteboard markers in their everyday lives, at their jobs, and so we thought that they would be a good consumer base to gain data from. And we also moved up a variety of subjects to get a variety of responses and perspectives.
So here's our next market research survey. This was just for our stakeholders. So we asked them to rate a bunch of different features. I believe it listed like 10 to 12 different features, and then rate them. So our highest was replaceable ink cartridges. That makes sense. We were talking about that a lot in a lot of our surveys and our correspondence. Chisel tip shape, so that's the tip shape. So like just like X markers, a little chisel right there. Pen-like retractable tip. That was something that surprised us because we did not think that was something that a lot of people were interested in. And then lowest rated was built-in eraser and accessible for your kids to use. It might seem weird, but remember, this was sent to high school teachers who don't really need to worry about whether or not an elementary school kid can refill a whiteboard marker. And then we also have our parameters. This was the focus on what we'd actually be interested in actually figuring out. So eco-friendliness was rated the highest, and longevity. And then the lowest was actually cost, being similar to other markers. And that gave us a lot of freedom going forward, because cost is a really, really difficult thing, especially when you're thinking like eco-friendly. It's hard to do the same thing and be within the same price point. As you see here, I'll gloss over this, but here's just a list of a bunch of different competitors. We've already talked about most of these. The ones we haven't about Link Pro, and those are the really crappy, tiny ones with the built-in erasers at the back. No one likes using those. And then when we asked how much specifically people would be willing to pay, we had about 50% say more than $350. Despite that, we decided not to go over $350 because I don't think anyone would want to buy a marker that's $4 or $5. It's just kind of a lot to make consumers want to buy. And then how likely are to purchase this product? We had majority say likely, and we leaned, generally speaking, in the positive direction.
So next, we wanted to consider a variety of factors when developing our design. First, we wanted to consider the eco-friendliness of these markers. As Logan mentioned earlier, that was rated the highest priority amongst our stakeholders. So we wanted to make sure that we were factoring that in, as well as the longevity and lifespan of these markers. We wanted to make sure that they would be able to last just as long, if not longer, than the original markers. And also, we wanted to make sure that they would be able to be refilled relatively quickly, just with a cartridge, rather than with the Osprey markers where it's dripping one drop at a time, as well as keeping that chisel tip shape, because that's, in order to make that transition from one product to another easier for consumers, as well as keeping our costs on the lower end. Even though stakeholders did indicate that they would be willing to pay a higher price, we still didn't want to go over that kind of $80 range, as well as just making sure that it's easy to use and accessible. Next, we're going to talk about exactly how we went about creating a design itself.
So we created a lot of sketches, and we all created, I believe, 10 sketches combined, and then we filtered the ones that didn't work or were the same down to about 4 sketches. So the first sketch was actually making a pressurized ink system. The idea was that it would actually shoot ink in really quickly, it would refill quickly because it's pressurized shooting in. The biggest issue, obviously, though, would be anything pressurized, especially with ink. You don't have any issues in transportation or have it explode on shelves or in someone's hand. That's a lawsuit, no one wants that. Especially, you don't want it to end up having to carry around those little tags around with expensive clothes and items. You don't want that exploding randomly anywhere. It's just too much risk.
And then our second sketch here was kind of going for the idea of almost like a syringe. However, some issues with this design are that the walls of it would be just simply too thin to be able to withstand the pressure of ink as it's pushed through to the tip, and overall it's just a very cheap design. And then with this next sketch, I got heavily inspired by the Gatorade GX bottle. The fact that you push down on the flavor pod and it'll empty completely into the water. I took that concept and put it into a whiteboard marker. So you would push down on the top of the marker with the ink, and then it would empty completely. You could throw away the ink cartridge, and you're good to go.
And then here's our fourth sketch. This one is actually just the pen click system. So pen like as in just any pen, you click it in, tip goes in, click it in, pen goes out, tip goes back out. This would actually be separated in the middle, so you could unscrew it, put a cartridge in, then screw it back in, and it should work just fine. Our idea was that if we could actually put the tip inside of the actual casing when it's not being used, it would be protected from more elements than if it was just in a thin cap. And then we made a decision matrix to actually decide. So we had a bunch of drawings here, we rated them all on our specifications. The more important ones were weighted to be higher, and eventually that last drawing was the one that we decided. Sorry. Now, a couple quick things, just why we chose this design. It's obvious that, especially when you want to make an eco-friendly marker, the first thing that you'll probably think of is make eco-friendly ink, right? First off, we don't really have any of the qualifications to do that safely. A lot of things that are actually in ink are found in paint thinner, which is not something that we really want to work with, obviously, especially considering our inexperience. Secondly, there are actually people trying to develop it, and they've made no progress in the last 5 years at all. So as great as I think we are, I don't believe we'd be able to solve it, and it seems like a very complex issue to find. Secondly, our goal is just to reduce the amount of waste. We're not going to be able to completely eliminate waste. Unfortunately, that's just not within our realm of possibility. It's very difficult. Expo markers just are a thing that if you keep using whiteboard markers, there'll be some form of waste. Our goal is just to minimize it. So we have a system where we're able to basically create something that never has to be thrown out. So at the very least, we can limit the amount of plastic waste that's being contributed to.
And so next we're going to talk to you about how exactly we went about constructing a prototype itself. So we have some CAD drawings here from Fusion 360, the software we used to design it. Just a general overview of what our marker actually looks like.
Here's our first prototype. So this is very early on, about like 8 weeks ago, when we started first actually creating this. This was pretty much just a 3D model we took offline, just so we could figure out if it would work. This didn't even work somehow. I don't know why it was online. It just doesn't work, right? But we kind of just use it just as a starting point to figure out like what measurements and constraints we'd have. It wasn't until 3 weeks later when we finally actually made it work. So we figured out that the biggest thing that was missing in the design was you had these little channels in here that stopped our top part from rotating. And after dimensioning everything, we ended up with just our bottom half. This took probably the longest amount of time to model. And then here's our third prototype. So you can see there was a lot of attempts. This is probably about $200 in printing, just because of the supports alone. It's very expensive. The first inner casing designs were created. So these are these. These are actually inside and holding the tip and the ink. And then we finally find springs for the bottom cartridge. And then fourth prototype. So these are all of our lid stuff. So this is when we're figuring out the lids. This was our first completed design that actually functioned. And the spring that we actually used ended up being a spring that Devin's mom had in one of her hair clips, actually. We looked everywhere online. No one sold springs that small, so we ended up having to deconstruct a ton of hair clips so that we could actually do testing. Yeah, so I have like a bag of like 5 of them still. And then here's the final prototype. This is this. Still works pretty well. And then here's an assembly video, maybe? Nope, okay, well, didn't upload yet. That's unfortunate, okay.
Okay, so throughout the process of creating our 4 sets of prototypes, we highlighted and documented some of the steps that were major within the process. So with this first picture here, this is the Stratasys. This is our 3D printer that we use, and it uses a special type of support material in which you can't remove with your hand, and you have to put it in this wash tub, as you can see here, in order to dissolve it at around 70 to 85 degrees Celsius. And then this last photo over here is us putting the ink cartridge into the inner casing to see if it would open it. And then now, trying to seal the marker, these 2 photos here are related to that. So this one here, we tried to use hot glue to seal the little gap in between the inner casing and the tip. But then, with the inner casing itself, since it's a 3D printed model, there's tiny little holes, so it'll cause it to leak. So instead we used acetone and we double boiled it, and we put it in there in order to seal it off completely. And then
with these photos over here, this one over here is just us assembling the marker together to see if it'll all fit together. And then lastly, this is us working in Fusion 360, and we're specifically working on the lid. And then also, instead of construction photos, we did incremental testing around each step of the process. So this one in the top left, this is us just checking to see if the click mechanism works. Okay, so now moving on to the next part, we're testing it. And we did 4 series of tests, and we did 4 different procedures. Okay, so the first one is a click mechanism test where we tested if the click mechanism would work every time we go to its proper state each time. We did 200 trials, and only out of 200 times, it failed 4 times. And then moving on to the writing test, we just wrote on a whiteboard marker to see if it would write clearly and consistently every single time. And we have a video here of it.
That was his first time.
Okay, there's the third one. Okay, so the third one is the leak test. We just left it out in certain positions, either left out vertically or horizontally to see if the marker would leak. And at first when we saw it, it did not leak at all horizontally, but however when we did it vertically, due to poor sealing, it was leaking a lot, but when we sealed it perfectly, there was no leaks at all whenever it was placed. And then for our final test, with the lid mechanism test, this is just us trying to see when we extend out the tip, if the lid goes out, and then when we retract it back in, if it goes back to its proper state.
Nadia's off so you don't get to hear our elated screams that it finally works. So there was a lot of significant design changes. I wish this had everything. If it was, it would be 5 slides long. I spent about 8 weeks on a computer doing nothing but modeling until things finally worked. The biggest changes were like just really, really tiny changes. There's so many times when we printed something and we changed something by 0.1 millimeters and then it just entirely stopped working. And I wish I was joking that that's how small the measurements we were dealing with are, but we're not. It took a lot of trial and error, especially when each attempt takes 2 days to print. So you really have to be accurate with your time, especially considering how short of a time span we actually had to do a lot of these things.
And then also it was important to consider if this was to be actually manufactured and marketed and sold to consumers, whether this would be manufactured in a large manufacturing setting or a small scale manufacturing setting. Here at Shakopee High School, we engaged in small manufacturing. We used 3D printers. However, with the support material from the Stratasys, it did end up costing a significant amount for every print, and it was quite slow. We also did outsource our ink to the ink cartridges from the pilot V-board markers that Logan talked about earlier, just because we don't have the resources or the knowledge to be able to actually do ink synthesis. And then it also just took a large amount of time compared to with large-scale manufacturing, where we'd be able to have this on a conveyor belt, a production line, and we'd be able to speed that process up very quickly. We'd also be able to engage in automation, which would lower the cost in comparison to small-scale manufacturing, and we could actually look into how we go about producing ink ourselves, as we would have the resources in an industrial setting.
And it is thanks for listening. Who has questions? Before, actually, you guys can yeah.
So you can share that with the stakeholders and have.
Yes, we already shared this. So about a week ago, we shared a recorded version of a presentation already to all of them before we even created this final slideshow, just so we could get feedback and figure out what we wanted. Just because we kept going over the whole time, like way over. I think our first presentation was 40 minutes long, which doesn't quite work. So we had to cut a lot of knowledge. So yeah, we've already sent to all of our stakeholders. They've already tested it. We have the feedback on our portfolio, which is out there if you want to see it. Anything else? I get points based on if you guys ask questions.
What's the feasibility that you could actually make a device like this? Like, do you think you could sell this?
It's difficult to tell, obviously, because we didn't have the resources to like actually do like a lot of tests with like different groups. Don't know what the term is, but our goal is if we were to probably first of all make it a bit smaller. I feel we have a lot of people actually the size like this way feels fine, but this is a bit cumbersome to be entirely honest. I'm sure a lot of you can tell this is pretty big, and with of course more time, we'd obviously be able to market it a lot better and change some things around to make it more closer to what Expo does, but just different enough to stand out in the market.
Can you write it on the board? I want to see it.
Sure. See if it works. So it's not perfect, but yeah, this one died. Unfortunately, actually, we had a sealing incident the other day because acetone is very difficult to deal with. So what happened recently was one of our parts broke actually, which is terrible timing because I'm not lying. You're gonna have to trust me here that we've never had any of our parts break until yesterday, at all. And we didn't have time to print it, or they tried to print it.
I don't believe it.
It failed. The print failed. However, we can actually put another ink cartridge in here, because this one, I believe the one that we have is gold, so it's actually completely empty right now. Yeah, this ink cartridge is actually completely empty right now because we've already used it all up. But we could put another one in, and it should work just fine. The issue is not with the tip, it's mostly just sealing. It's very difficult, and then if we injection mold, like how we would do it in large scale, we wouldn't have to worry about acetone at all, because it would be solid in structure instead of having to put something over it to make sure it's solid. Yes?
Is there a way that the design would eventually get a little more compact? Because with the way it is right now, the probably like biggest concern would be that it might get uncomfortable to hold the marker with like the size of it.
Yes. So actually, that was going to be one of our things if we had more time, because we were looking into it, but by the time we were at this point where we had to worry about making our lid, but the biggest thing that takes up size is actually this bottom casing part. The top casing we can only do so much in because this is actually where the ink is stored. We could obviously make it shorter to store less ink, but that'd be something where we'd have to do a lot of market testing to figure out like how much people actually want it shorter versus the lifespan of it. A lot of this could be cut down though. We've discovered that changing the channel sizes and changing the piece sizes would save us a lot of space. We really just didn't want to redesign anything because it's a miracle that this ended up working after 3 weeks and we just didn't really want to touch it again. We did end up having to change sizes to make it move more, but yeah, we could probably make it about, I want to say like a centimeter or two shorter, but nothing more than that. Yes.
You'll never lose it.
Yeah, well, you'll never lose it, that's for sure, yeah.
Nobody will want it.
I was wondering about the exchangeable tip. You mentioned that the tips would wear out on the other ones. Is yours an exchangeable tip as well?
So right now it's not, unfortunately, again, because of the what's it called, the 3D printed like actual filament. We can't actually create a seal very well around the tip. Ideally, it's been done before already. When we've actually looked into how it's been done, because Ospen does the same thing. It just comes down to like really, really precise molding, and unfortunately 3D printers, while they're good, they're not injection molding, right? So there will be small errors, meaning that when we printed, sometimes it fit perfectly and not leak, other times it wouldn't. So we ended up just going with the easiest method, just to glue it, because we didn't want to deal with spending more of Mr. Hendrickson's budget on reprints. Yes.
Speaking of the tip, I'm fascinated by this 90+% of teachers thinking a chisel tip is important, because I could care less. Like, how, in the wording of the question, did they know that a rounded tip would be an option, or was it just like, either a chisel
the
tip
the specific wording that we used was, we asked if they wanted a tip that's the exact same as how Expo does it. So we actually asked to compare it to Expo in our question.
Okay.
Yes, actually, we don't have the survey in here right now. But we do have the survey where we sent out, we still have everything documented. Yeah, we just said similar to Expo marker because not very many people know what chisel tip is really implying.
Okay.
Did you come up with like an estimated cost then of what this would cost? And I know one of your slides said that cost efficiency was important, or slightly important.
We wanted to estimate, our guess was around like $350 at tops again, which is very convenient, but we asked a bunch of experts on that, and really it's hard to tell just without like knowing exactly what material can be using, and then obviously large scale manufacturing, you have to ask a manufacturer. The most expensive thing for sure would be the funny enough, would actually probably be these springs, because these are really annoying to get. Specifically, these sizes are super specific, and you have to buy them all in bulk. And then probably again the casing, but our goal is that again, it will be expensive on the initial buy, probably like $4 at tops maybe. But once you buy a casing, you don't have to worry about it, because you can actually replace, here, let me show you. You can actually replace this part, if I can take it out, this with any other tip color. So you could just have multiple of these too, and just replace them. So you don't even necessarily need different markers or different colors either. The goal is, the only thing you need to get are these, and these are about, I believe they're about 80 cents each. But our goal is, if they were to last 1 to 2 weeks, which is what they say they should, then you'd be able to have, instead of buying an entire extra marker every week, you just buy one of these, which is cheaper. And also less wasteful, because there's less plastic in here. That's where we have time.
You have like under 4 minutes.
You get 2 more questions, and we should help the other groups that get set up. Anything else? Nothing? We're good? Great, thank you.